Chemistry class, we're back in the chemistry classroom to look at a demo today. As always, back behind the camera, I have my son Ethan. Say hi, Ethan.
Hello.
All right, so today's demo, we're going to look at factors affecting reaction rate. And so when we talk about reaction rate, we're talking about how fast that reaction goes. So in chemistry, there's kind of four big things that can control how fast a reaction goes. And we're going to look at just one of these things. But the four things that can affect this reaction rate or how fast a reaction goes are the concentration of the reactants. So the more concentrated the reactants are, the faster the reaction will go. The temperature, the higher the temperature of the reactants, the faster the reaction will go. The presence of a catalyst, the faster the reaction will go. And then what we're going to look at today is how we can increase surface area and increase the rate of reaction. Well, all these things affect how many collisions you have of the reactants. And so the faster or the more often these collisions are happening, the faster the reaction goes. So if you can imagine, like if we take temperature, if we increase the temperature of a reactant, those molecules are moving faster. And so there's more collisions within the reactants more often, so the reaction takes place more often. What we're going to look at today is how surface area affects. And so we're going to take a reactant, and it's going to be like grain dust, which by itself doesn't have a lot of energy. If I just had a lump of grain dust, it has a pretty small surface area. But if I were to get that grain dust and really kind of spread it out, and then it's going to be surrounded by oxygen, that reaction rate can go pretty fast. And so let's come on over here, kind of look at our setup we're going to have. So this in here is our grain dust. And so I have a pipette that I'm going to suck up some grain dust in here. Again, not a lot of energy on its own. So we've got some grain dust in here. We have a paint can, regular paint can that I drilled a hole in. And I also have a candle that's down in. That's going to be our ignition source. So this is going to be a combustion reaction. But imagine the tiny amount of grain dust about the size of a pea. But when I blow it into the paint can with the lid on, it's going to expand about the size of, well, the size of this container. So I'm going to light the candle with my torch of science here. It's easier than trying to reach a candle down in there. So I'm going to light the candle. Okay, the candle is lit. I will then take the lid and hammer it on just a little bit. All right, now we're ready for the explosion. And here's your reaction. Wow, now that's a lot of fire. All right, so we had a reaction, a very small amount of grain dust, about the size of a pea, but when I squeezed the pipette, it expanded about the whole size of the inside of the container, so the surface area was increased by many, many, many times. And so that grain dust was then more in contact with the oxygen molecules more often, and so the reaction would happen quick enough. So in real life, these things happen sometimes in like big grain elevators. We have grain elevator explosions. And so you could probably Google at home like grain elevator explosions, and there'll be pictures from Kansas that may come up. But you wouldn't think normally that grain dust would be very explosive. But when you increase the surface area by putting it into a dust or a powder, the reaction rate can really be high. So hopefully you enjoy this demonstration. Have a good rest of the week.